Welcome to Retro Upgrade. Today we will be looking at how much it costs to actually set up a desoldering repair station. I bought some stuff from AliExpress. Let's start with this. This is a PD power supply. I went a little bit overboard. It's 330 watts total, 100 watts on two of the outputs. I needed this for the actual soldering pen because it's USB-C. But this is nice to have because I usually have a lot of things plugged in. The two ones on the right are 100 watts, then the other ones are 30 watts. And these are really nice to have extra. I've already opened this because I'm using this to charge my phone and other stuff, and it actually frees up a lot of space. The reason I'm doing this is I want to replace my soldering station that has a soldering iron and stuff. I also bought a high quality USB cable. This is USB 4, but it works as a USB 3. This can take up to 240 watts, so more than enough. Good thick cable, decently flexible. So this would be fine for the soldering iron. I can also use this as high bandwidth USB 3 cable as well. These are interchangeable, by the way. Not too bad. Also, I don't have a USB 4 port on my computer yet. Going to fix that soon. This is my old soldering iron. It's one of these old style ones that has the heating element inside the handle. And if the heating element breaks, you have to change out the heating element. The new one is T12s instead and has the heating element inside the tips. Also, this requires good thermal conductivity, and usually it struggles a bit to deliver a lot of heat. Otherwise, this has worked very well for 7 or 8 years. Let's look at this one. This cost me about 70 euros. It was really cheap. Comes with one tip. It's a 65 watt. And you can actually push it to 72 watts, but you need to use the included barrel jack for that. Otherwise, you have, and it uses PD for then 65 watts. The instruction booklet is basic, nothing special. The packaging leaves a little bit to be desired. So this works from 10 to 74 watts, like it says, 9 to 24 volts PD, QC, or DC. So it can actually use quick charge, but quick charge doesn't go over 12 volts, if I don't remember incorrectly. It comes with the lead for the DC thing, so that's good. It looks decent. I like the design, good rubber grip. Also, the USB-C connector is really good, and that's why I bought the charger, obviously. These are T12 tips, and they have the heating element integrated. So even if this breaks mid soldering, I just get another tip, and you have a working soldering iron again. So these are perfect for my use case. And I also bought a few extra tips because I like to have variety depending on what I use them for. This is a 8-pack, cost about 15 euros. This is optional, obviously. If you're going to start soldering, just use the one included and you're fine. Let's open up a wedge tip so we have something to compare with. My old soldering iron has one of the wedge tips on, that's why I compare them. The collet you see is actually not necessary to put on, but it's a good practice to do so. This requires a little bit of force to put down. You can see here the collet is not all the way down. Now it should be. So if you want to be able to change the tips while using the thing, you have to do the collet thing. But I strongly recommend turning the soldering iron off to do so, just pulling out the cable pretty much, so you don't short anything inside. The thing I have on the top there is an old USB hub. I'm just salvaging some parts from it. Here you can choose what voltage you want. It was set to 15. I want 20 volts. I want the max wattage. So this is 65 watts. It heats up pretty quickly, actually. Not too bad, 14 seconds to 350 degrees. And the wedge tip looks nice. Doesn't discolor like my old one does. It discolors immediately when you go on high temperatures. Okay, let's do one the easy way, putting leaded solder on. And yeah, I know, I need a thicker solder. This is the 0.3 solder I usually use. This is a tactile switch, or a switch, a normal switch. I use these on different projects, so I like to salvage them from these old USB hubs. Now to do it the hard way with no leaded solder. This takes a little bit longer, but usually if the soldering iron has enough thermal mass, this is easy enough when the contacts are this close to each other. Yeah, works fine, no melted plastic, perfect. So far, good enough. Let's do a test with my old soldering iron as well to show exactly what's happening. To turn this off, you just pull out the USB cable pretty much. Okay, back to my old one. It's beat up, old, 7 years old. This cost 250 euros back in the day. The entire station with the hot air, power supply, multimeter, and the soldering iron. Came with one tip. I set it to 250 degrees, just like the other one. Sorry for the blurry mess. I'm trying to fix the camera here. And this one takes longer to heat up. I have verified the temperature on this with a thermocouple. I'll do that in a while. But it's pretty accurate. I have to check the new one as well for this, so I'll do that after. It's taking way too long to heat up, so my head popped out. There we go. Let's do it the easy way. 50 seconds to heat up, so about 3 times slower. And I think the measurement is on the actual heating element and not the tip. So as you can see, it's struggling to melt. It will get there eventually. This is what I mean with the thermal conductivity of the heating element towards the tip. They're not joined together, but it did work at the end. So the best tool for the job normally is the one that you know best, even if this makes it a lot easier with good tools. I'm used to this tool, so I know exactly the limits of it. But as you can see, even knowing the limits, it's hard to get it to let go. Of course, you can use solder wick or solder pump, and this would be a lot easier. But the point was, I was going to do the same test on both. It's still decent. I like it. This is going to one of my friends afterwards, the entire soldering station. But for now, I'll keep it until he needs it. Okay, let's verify the temperature. So first up, my old soldering iron. It should be 350, and so it's spot on. So exactly like I remember. It's very reliable that way. Unfortunately, it has some problems keeping that heat if you go for a big power plane or a ground. Let's test the new one. The new one has a slightly smaller tip, so it's hard to get good contact with the temperature reader or NTC or whatever you want to call it. This is a thermocouple. Yeah, 350, spot on. So perfect. Usually Chinese stuff is not very good with accuracy, but in this case it was. This is the old hot air gun. It's connected to my station here. And you can choose the speed, the temperature. You also have the voltage and the power supply on the side. And it's quite thick and heavy. It takes up a lot of space on my table. I have it hanged up here, and it has a magnetic base. So it doesn't turn off until it senses the magnetic base, and you can actually turn it off. Now, a quick word for my sponsor, PCBWAY. A big thanks to PCBWAY for always sponsoring my videos. They have excellent PCB manufacturing, quality control, and also professional expertise. They also have manufacturing of metal parts, plastics, and other things with CNC milling, metal sheet fabrication, and also high precision. Of course, they have testing machines to make them extremely accurate. And of course, they have 3D printing services. They have a lot of different processes you can choose from: SLS, SLA, FDM, and a few more as well. They also have multi-material, high quality, of course, as usual. They also have a great deal for 10 PCBs for $5, up to 2 layers, and assembly. This is used by me a lot. Thank you, PCBWAY, again for always helping me out and keeping me around. Now back to the video. Okay, so this is my old soldering iron, or desoldering hot air thingy. It's just put in with pressure. It's decent enough. I've done very delicate work with this. This is my new one. So it's 22 euros, thereabouts. It's exactly the same as the entire station, but it's all integrated in the handle. It also comes with an extra heating element. That's really nice. And 3 different tips for it. Also very nice. And these are a little bit different, but still same type. Okay, so let's check the manual. Let's see, is there anything important here? No, this is just garbage. Let's see the other one. The tips look, the tips look nice. So they have a screw-in system instead of the other one, like you just press on. These are more reliable and easier to change out when it's hot as well. It uses a small screw and a small bolt-like thingy. A little fiddly to put on the first time, but when it's on, it stays there, so good enough. And you get 3 of them. The square one is really good for ICs. Okay, let's test this out. I will do a side-by-side literal test. I will desolder a chip as well from the USB hub that I don't need, but it has 2 of them, so it's a good comparison. It has some information on how to change the heating element and how to set it up and stuff, but it's very intuitive. It has an on-off switch on the top, so that's really nice because the other one is missing that. Even if you turn it off when it's full heat, it keeps the fan on until it's cold. Compared to the other one that if I turn off the power, the heating element stays at that temperature and doesn't cool down with the fan. It heats up really fast. That I liked, actually. It's very intuitive. Let's check with the thermocouple, see if it keeps that temperature. Okay, I screwed up here. Multimeter is out of shot. I'll fix that. So with hot air, the temperature is kind of important to keep stable. Because if you pump in too much heat in something, you'll probably break it or melt the plastic around. So about 300 exactly. Airspeed is a little lower than my stations, but not too bad. You can set the fan speed there up to 10. And 10 is about number 8 on my station, so it's a little bit slower, but the high speeds are not really useful. It usually just blows away components, which sucks. Unfortunately, I forgot to turn on the mic when I recorded this video, so no sound, but noise levels about the same, so No worries there. Professional YouTuber here, by the way. Let's see the max temperature, 500. Not too bad. Let's see if it holds out. And it pumps out quite a lot of heat. I melted a plastic thing on the side, by the way, in the line of fire, but yeah. You see the blinking light? That indicates it's still heating, so good enough. It's struggling a bit to get to 500, but usually I don't use it at that temperature. It's actually almost melting the shrink tubing around the... But it got to 500, so that's good enough. I'm probably going to use it between 300 and 400. About 60 seconds to cool down from 500 degrees to 100 C, where it shuts off. Not too bad. My other one is about the same. It takes a while to cool down before it shuts down. This also has a small stand, a metal stand you can just flick open. Okay, let's try my old one. I'll just speed this up for consistency, but I put it at 480 degrees. It doesn't have 500 C. But as you can see, it's not very accurate. It goes a little bit over, but it's still workable. Okay, so let's use the new one to desolder one of these controller chips. This time I'll be using flux because it's a lot easier that way. I'm lazy like that, but this is the correct way to do it, by the way. So I'll put it at 350 again. Some tweezers. Usually good idea to have those. I like the small design because the other one takes up the entire bench pretty much to do the same. So it's still heating up. This is from complete cold, by the way. And the top one, it was actually heated up first, so because it takes so much longer to heat up. So the speed comparison is not really fair, but fine. But as you can see here, the tool that works mostly is the tool you are used to. Even if this actually hot air gun is worse, I managed to take off the chip faster. But yeah, like I said, when I get used to this one, it's probably a lot better. Okay. Now for the extras my station has. If you want to go all the way, you can buy one of these. This is a 80-watt variable power supply. I made a video on it. I'll put a link in the description. And this is my station now. So this is the closest I could find. And it cost about 127 euros with the shipping. And yeah, that seems about right. And the total cost for my stuff is a lot cheaper than this. And it's probably worth buying it loose like I did. Even with the extra tips and the power supply unit and a random multimeter, because this has a multimeter included, you're still under 105. But considering you're at $59 or euros with the PD power supply, the USB soldering iron, and the hot air, and that's all you need really. And let's say you need a PSU as well for testing, it's $15 more, but it's still good. So I would recommend buying these loose parts. I'll put some links in the description. They probably break after a while because AliExpress is not reliable like that. Okay, that's all for today. Thank you for watching until the end, and hopefully you have a nice day and see you soon. I'll promise I'll make it faster this time. Bye.